we are going to jump right into your first lesson in geometry, and that is on clocks. So first, let's talk about some things we know about a clock. We do know that a clock is circular. That's a given. And if you'll recall from some of your previous math classes, there are 360 degrees in a circle. Now, on our clock, we have 12 of the large numbers, and we're going to assume that they are perfectly evenly spaced around our circle, which means that in a 360 degrees, if I divide that into 12 equal portions, each interval between numbers is a 30-degree angle. Now, hopefully you also know from telling time that there are 60 minutes in an hour and 60 seconds in a minute. Okay. Now, this clock is showing 10 o'clock right on the top of the hour. We know that our minute hand moves faster than the hour hand, and this clock does not have a second hand on it, but the second hand moves even faster than the minute hand. Now, drawing your attention down to number 4, does our hour hand stay on the number the whole hour? And the answer to that is no. As the hour passes, the hour hand slowly moves closer to the next number, and it does this proportionally depending on how much of the hour has passed. So we're going to do some practice problems with this. The first one is at 12:15. We're going to draw this on a clock and calculate the angle between the hands of the clock at this time. So get out your sheet with your clocks on it, and let's work this out. So if you don't have this sheet, you can just draw clocks by hand. And so the first time that we are going to be solving for is 12:15. So at 12:15, my hour hand is pointing somewhere in between the 12 and the 1, because remember, it slowly moves towards the 1. And 15 minutes, my minute hand will be at the 3. Remember, the interval between each of the large numbers is 5 minutes. So here's what my clock looks like, and I want to find the measure of this angle. Well, as we already talked about, when we've got a 360-degree circle divided into 12 equal sections with our large numbers, we know that the intervals from number to number are each 30 degrees. So this is 30 degrees, and this is 30 degrees, from 3 to 2 and 2 to 1. Now, the last piece of information I need to find the total angle measure is to find this angle measure between the 1 and the hour hand. Now, the hour hand has moved proportionally to the amount of the hour that has passed, so 15 minutes out of the total 60 minutes in an hour have gone by, or 1/4 of an hour. So this hour hand has moved 1/4 of the way in between the 12 and the 1. So it's moved 1/4 of 30 degrees towards the hour, towards the number 1 on our clock. So you can do this by hand or in a calculator. 1/4 of 30 is 7.5 degrees. So this measure right here, from 12 to where my hour hand is, that is 7.5 degrees. Which means from this hour hand to the 1, sorry, it's getting blurry, focus, would be the difference of 30 and 7.5. So 30 minus 7.5, which is 22.5. Sorry, it's blurry again. Come on. Come on. Okay, that's better. It's in focus again. So to find the total measure of that angle, I'm going to add 30, 30, and 22.5, and that is going to give me 82.5 degrees. So the measure of the angle at that point is 82.5 degrees. All right, let's practice this again. Go down to one of the smaller clocks at the bottom, and I want to find the angle between the hands of the clock at, sorry, that should be 1:30. 1:30. So at 1:30, my minute hand is pointing at the 6, and my hour hand is pointing exactly halfway between the 1 and the 2 because it's half an hour has passed. So let's count how many whole intervals we have. We have from 6 to 5, 5 to 4, 4 to 3, and 3 to 2. That's 1, 2, 3, 4 intervals that are each 30 degrees. So that would be 120 degrees. Now I just need to know this measure here from the hour hand to the number 2. And it's halfway between that, right? 30 minutes have passed out of the total 60 minutes in an hour. So that's half of an hour. So our hand has moved halfway between the 1 and the 2. And we know the whole thing is 30, so half of that is 15. So my total angle measure here would be 120 plus 15, and that is 135 degrees. Okay. Let's do another one. Let's do 2:55. At 2:55, my minute hand is pointing towards the 11, and my hour hand is pointing between the 2 and the 3, but almost towards the 3 because it's been almost the full hour. So let's find this measure. I've got from 11 to 12, 12 to 1, and 1 to 2 are entire increments. So that's going to be 90 degrees, 30, 30, 30. Now I need to find this measure here. So 55 minutes out of the total 60 minutes have passed, which is equivalent to 11 over 12. So 11/12 of the hour have gone by, which means that our hour hand has moved 11/12 of the way towards the 3. So I need to find 11/12 of 30 degrees to find out what that angle is. So I can do that in my calculator, and we get 27.5 degrees. So 90 plus 27.5 gives me 117.5 degrees. Okay. 2 more. Let's do 9:45. At 9:45, my minute hand is pointing at the 9, and my hour hand is going to be pointing between the 9 and the 10, closer to the 10. So we want to find this angle. So I don't have any complete intervals here. We just have this measure between the hour hand and the number 9. That's what we need to find. So 45 minutes out of the total 60 minutes in an hour have passed. This is equivalent to 3/4 of an hour. So my hour hand has moved 3/4 of the way to the 10. We know the whole distance is 30 degrees, so I need to find 3/4 of 30 degrees. And that would be 22.5 degrees. Okay. Last one, and this one is a little tricky, so make sure you're paying extra close attention here. 11:27. So at 11:27, my minute hand is going to be pointing between the 6 and the 5. So let's draw in our little tick marks here, because there's 5 minutes in between here. So that would be 25 minutes, 26, 27. So 27. 11:27, it's going to be in between the 11 and the 12 is my hour hand. Okay, so let's look at our whole intervals. We have from 11 to 10, 10 to 9, 9 to 8, 8 to 7, and 7 to 6. That's 1, 2, 3, 4, 5 intervals that are each 30 degrees. So from the 11 to the 6, that's 150 degrees. Now what's different about this one is we have 2 partial pieces to find. We need to find from the 11 to the hour hand, and we need to find from the 6 to the minute hand. We need to find both of those angle measures in order to get the total angle. So let's do from the 11 to the hour hand first. We've got 27 minutes have passed over the total 60 minutes in an hour. This is equivalent to 9 over 20. So 9/20 of the hour have passed, so it's 9/20 of the way of 30 degrees. So we need to find 9/20 of 30 degrees. And that's equal to 13.5 degrees. Now we can find the measure from the 6 to the minute hand. We know this entire measure from 6 to 5 is 30 degrees, and that we have divided it up into 5 equal segments to represent each of those minutes. So the angle measure between each tick mark minute would be 30 divided by 5, which is 6 degrees. So the angle between each of these tick marks is 6 degrees. And from the 6 to where my minute hand is pointing, I have 1, 2, 3 tick marks. And those are each 6 degrees, so that would be a total of 18 degrees. 6 times 3. Now, last but not least, we need to add up our total. 150 plus 13.5 plus 18. And that gives us, for this angle, 181.5 degrees. Now, when we're finding the angle between the hands of a clock, we want to find the smallest angle. This is not the smallest angle because this is more than half of my total angles in the clock. So what I want to find to get the smaller angle is this angle measure on the opposite side. And I'm going to do that simply by subtracting 181.5 from 360. And I'm going to get 178.5. So 178.5 degrees is the angle measure between the hands of the clock at 11:27.